In this video, we're going to focus on solving one-step linear equations. So before we start solving equations, I want to talk about a couple of key vocabulary terms. The first is an expression. An expression is anything that contains a combination of letters, numbers, and operations. And expressions can only contain these three things in some combination. So what this means is that an expression could just be a letter, so just a variable, such as x. An expression could also be just a number, like 10. And then an expression can also be some combination of letters, numbers, and operations. So for example, something like x plus 10. That's an expression because it contains either letters, numbers, and or operations. You could also have something like 6b squared plus 17c. Again, you have letters, numbers, operations, because b squared is really b times b, and that's it. So that's what an expression is at its most basic level. Then from here, an equation is something a little bit different. An equation is two expressions set equal to each other and will contain an equals sign. So what this means is that an equation and an expression are two different things, and our vocabulary does matter. An expression contains just letters, numbers, and operations, while an equation contains an equal sign that sets two expressions equal. So for example, you could have x equals 10. You have letters, numbers, operations, those are your two expressions right here, and they are set equal with an equal sign in between. You could also have something like x plus 10 is equal to 6b squared plus 17c. Again, you have two expressions, things that contain letters, numbers, and operations, set equal to each other with an equal sign. So that equal sign is really the key to an equation. And then lastly, a solution, which is what we'll be finding today. We'll be finding solutions to equations. A solution is a value that makes the equation true. So for example, say we have the equation 5 times x equals 10. That's our equation. We have two expressions set equal to each other, and we know that 5 times 2 is 10. So we know that if x was equal to 2, that solution would make the equation true. And that's ultimately what we're going to be finding today as we look at solving different types of equations. So a one-step equation is an equation that we can solve in one single step, and most of the time these are equations that students can sometimes solve in their head. So for example, here, if we look at this first example, we have m plus 12 equals 10. So we have to think, okay, 12 plus what number would give us 10? Well, m would have to equal -2. Then from there, if we look at the second one over here, we're thinking, okay, g minus 9 gives us -2. Well, what minus 9 would give us -2? That would be g equals 7, because 7 minus 9 is -2. If we look down here, remember items smushed together imply multiplication. So this is saying a -7 times y equals 63. Y would have to be a -9, because 9 times 7 is 63, and negative times negative is a positive. And then over here, we have a divided by 9 equals -4, which means a would have to be -36. So when we're solving equations, we're looking for the answer for that variable value, that if that value was placed in for the variable, it would make the equation true. Now with one-step equations, as I said, sometimes we can do these in our head, but other times we might be struggling a little bit. And over the next few slides, we're going to look at strategies that we can use that will help us to solve one-step equations in a more systematic fashion. So solving one-step equations using some steps ultimately stems from the fact that we want to undo what's happening to our variable over on the one side of the equation that it's on, so that we can get that variable alone and find out what it's equal to. Now here we have x plus 4 equals -15, and ultimately we would like for this x value to be by itself on the left-hand side of the equation. Now, in order to get x by itself, right now it's x plus 4. So what we can do is we can add a -4 to each side of the equation. By doing that, on the left-hand side, we'll have 4 plus, that's a negative 4, and that will ultimately become 0, leaving just x equals. And then on the right-hand side, we have negative 15 plus negative 4, which is negative 19. Now, some of you might be questioning what just happened, and realistically, what we know about equations is that both sides of the equation are equal. So that if we change the left-hand side in some way, and we change the right-hand side in the same way, we're really not changing the values of x, which is the important piece. So here, we were able to get x alone by adding negative 4 to each side. And then from here, we can actually check our answer if we're not sure. By going back to the originals, we had x plus 4 equals negative 15. So if we have negative 19 plus 4 equals negative 15, well, if we add these two together, we get negative 15 equals negative 15. So we've essentially proved that x equals negative 19 is the value that will, in fact, make this original equation here true. Now in this example here, we're going to undo subtraction, or you should know, because of keep, change, that we are undo adding a negative. So here, these two problems are exactly the same thing. They're just represented in two different ways. And what we need to do is we need to get the x value in each alone by undoing the subtraction or undoing that addition of a negative 10. And remember, subtraction and adding a negative are the exact same thing. So I suggest always writing things like keep, change. So that's what we did over here on the right-hand side. But if you like subtraction and you keep it as subtraction, that's okay too. So what we can do here is we notice that we have a negative 10 on the same side of the equation as x. And in order to get rid of that negative 10, we would have to add 10 to the left-hand side. And then remember, whatever we do to one side of the equation, we must do to the other. And as we do this, negative 10 plus 10, that becomes 0. So we just have x on the left-hand side. And 12 plus 10 gives us 22. Now we could have applied that same thing over here. I just like to write it as keep, change, so that I don't have any sign errors down the road. Now if I wasn't sure, I could check my answer here by doing 22 plus a negative 10 is equal to 12. Well, I know 22 plus negative 10 is 12. And as a result, I have a true equation. So here we can see that if we are adding a negative number or subtracting, we can simply add to undo that operation and get the variable by itself. So here we can see that we have an equation that contains multiplication of x and a number. So we have 3 times x equals 27 and x times 3 equals 27. And ultimately, these are again the same since multiplication can be done in either way. And the way to undo that multiplication and to get the x by itself is to use division. So here we can divide both sides by 3. So 3 divided by 3 would give us 1x. And 27 divided by 3 would give us 9. So we're able to undo multiplication using the division operation. And then here we can check our answers. We can do 3 times 9 is equal to 27, which we know in fact to be true. So we can see that x equals 9 is the value for x that makes our equation true. And then finally here you can see that we have division going on. And what we can do here is we can undo division by using multiplication. So what I'm going to do is, because I'm dividing by 8, I'm going to multiply by 8 on each side. Now something to remember when we're multiplying by 8 is we're really multiplying by 8 over 1. So what's happening on the left-hand side here is I'm getting 8 times x divided by 8. And then on the right-hand side, I'm left with 5 times 8, which is 40. Now, 8 divided by 8, we know is just 1. And as a result, those cancel out, and I'm left with 40. And then if I wanted to check my answer, I would be able to substitute that value back in. So I'd have 40 over 8 is equal to 5. And then if I simplify that fraction, they're both divisible by 8. So here I would have 5 is equal to 5, which is correct. All right, so here we're just going to use the strategies we talked about on the last few slides to solve these 5 equations for their missing variable value. So in problem number 1, what I notice is that I'm multiplying y by a negative 5. My way of undoing multiplication is to divide. So we're going to divide both sides by a negative 5. Negative 5 over negative 5 leaves me with 1y. 35 divided by negative 5 leaves me with negative 7. So I know that my y value is equal to negative 7. Then from here in number 2, I can see that I have a negative number being added. My way to undo that operation is to add 15 to each side. So here, negative 15 plus 15 gives me 0. So I'm just left with w. 20 plus 15 is 35. So I know that w must be equal to 35 in order for that equation to be true. Then if I look down at number 3, I notice that I have a positive 12. If I add negative 12 to each side, what happens is these become 0, and I'm left with just x on the left-hand side. 10 plus negative 12 is a negative 2, so my x value must equal negative 2. And then lastly, on number 4, I see that I'm dividing w by negative 4. So I'm going to multiply both sides by a negative 4, remembering that this is really a negative 4 over 1 that's being multiplied there. Ultimately, on the left-hand side, negative 4 divided by negative 4 becomes 1, so I'm left with 1w is equal to 8 times negative 4, which is negative 32. And as a result, I've found my value for w that will make the equation true. And then finally here we're going to talk about what to do with those nasty fractions, and it's actually no different than what we do with normal integer operations. So if we look in this first one, remember this is a multiplication between the 2/3 and the x, so we're going to divide both sides by 2/3. I know that division will undo that multiplication, so on the left-hand side I'm really left with x, and on the right-hand side I'm just going to write this in a different way. It becomes 10 divided by 2/3. And then I need to go back to my review chapters where I talked about how to multiply and divide fractions. And here I know that I can rewrite this fraction of 10 as 10 over 1. I know that to divide fractions I use keep, switch, flip. So I keep the first fraction, switch division to multiplication, and flip the second fraction to its reciprocal. Then when I multiply fractions, I just multiply the numerators and multiply the denominators, and then I simplify, which I know both of these divide by 2, so I find x is equal to 15 over 1 or 15. Now the second one is the exact same way, even though it's a negative. So we're going to start by dividing by the fraction that it's being multiplied by. So I divide by a negative 6/5. So then I'm left with k equals 12 divided by negative 6/5. I use keep, switch, flip to rewrite this as a multiplication problem instead of division. I can then multiply my numerators, multiply my denominators, and I'm left with k is equal to negative 10 over 1 or 10. So fractions aren't any different. You just have to think about your fraction operations and how you add, subtract, multiply, and divide with fractions.